Hello viewers, welcome to this video. In this video, we're going to be looking at setting up a highly available Kubernetes cluster. Alright, so a year ago I did this video, kubeadm hache with multi-master. So all I did in this video, it's exactly a year ago. Anyway, I want to redo this video because I didn't do that properly. So what I did in this video, Kube 1.3, is basically this. We had two master nodes and all our interactions was through this load balancer. We set up a Haproxy in this load balancer node. We had the Haproxy configuration that load balances to multiple master nodes, and K-worker communicates, and every single Kubernetes components communicate with the API server through the load balancer. And again, your kubectl commands will go through this load balancer. You can already notice some problems here. So there's this load balancer, which is a single point of failure. So we need to make this load balancer redundant. So that's what we're going to be looking at in this video. So if I scroll, so this will be our new setup. So for this video, my setup is, so I'm running this entire video on my laptop, which is Dell XPS 9310, running Arch Linux, has 8 cores and 16 gig of RAM. And for this video, all my virtual machines, I'm going to be provisioning using KVM libvirt. But the vagrant file I've got in my Kubernetes repository, which I'm going to show you in a minute, work both with VirtualBox as well as libvirt. But for this demo, I'm going to be using libvirt, but the process is going to be exactly the same. What we are trying to achieve is a truly highly available Kubernetes cluster. We're going to be using a tool called Keepalived in addition to Haproxy. So if you look at the control plane, we already have multiple masters. So that's what our setup is going to look like. So we have 3 masters at the minimum. So we need to have at least 3 masters. And then instead of one load balancer, now I'm going to introduce another load balancer for redundancy. And then we're going to be using something called a virtual IP. So that virtual IP can travel between load balancer 1 and load balancer 2 depending on which one is available, and that is done using Keepalived. So all the components within your Kubernetes cluster will interact with the API server through this virtual IP, and this virtual IP will be assigned to one of these 2 load balancer nodes. Okay, so we have high availability for the load balancer plane as well as the control plane. So if load balancer 1 goes down, still the load balancer 2 can take the load, and this virtual IP has got logic in it. It gets assigned initially to one of these 2 load balancer node, and if a load balancer node goes down, the virtual IP shifts to another load balancer automatically. So you can continue to run your kubectl commands, and all your cluster components can interact with the API server. So all the virtual machines here are going to be Ubuntu 20.04, and I'm going to be using Kubernetes version 1.22.0. All the Kubernetes nodes, master nodes as well as the worker nodes, will have 2 CPU and 2 gig of RAM, and load balancer I've assigned 1 CPU and half a gig of RAM. You can have as many load balancers as you want, and you can have as many master nodes as you want. If you just follow the process that I'm going to show you, you can just extend your Kubernetes cluster to depending on your requirements, you can have more load balancer nodes. But for this demo, we're going to have just 2 load balancer and minimum highly available Kubernetes cluster setup. So let me show you my GitHub repository. Just me an open source Kubernetes. I'll put a link to this in the video description. Kubeadm hache Keepalived Haproxy, and inside that there's a directory external Keepalived Haproxy. So there are 2 ways you can achieve this. Either you can have a dedicated operating system, dedicated system running Haproxy and Keepalived, which is what we're going to do, which is what we're going to be doing in this video. Or you can have Haproxy and Keepalived running as static pods within each of these master nodes. So you can entirely get rid of this. So I'm planning to do that in my next video. Just for completeness sake, I'm also going to show that how you can do that. Okay, so if I show you my vagrant file here, you can see, so there is this load balancer count. If you want more load balancer, you can just update this variable, and I'm using Ubuntu 20.04. box version is 3.3.0, and 172.16.16.51 and 52 are the IP address for the load balancer nodes, and 172.16.16.101 to 103 for the control planes, and 201 for the K worker. Right, so that's load balancer node, and master count is 3. So we will be bringing up 3 master nodes. Again, everything's the same, and 1 worker node. So all uses the same vagrant box Ubuntu 20.04. And here you can see I've got a couple of blocks for VirtualBox and libvirt. If you want, you can do vagrant up. That will bring up all your virtual machines in VirtualBox. But if you want, like what I'm going to do do in this video, I'm going to be using libvirt provider. So you just need to do vagrant up -- provider libvirt if you want to bring all your virtual machines in KVM libvirt if you're running it on a Linux host. Okay, so that's the vagrant file, and I've got a bootstrap script, a little bootstrap script. Let me show you what's that. Bootstrap, all I'm doing is I'm enabling password authentication, and I'm also setting up the root password to be kubeadm for all my 6 virtual machines. Okay, so let's go back to the README documentation here. So the thing to note here is we will be using 172.16.1600 as the virtual IP. And if I show you the notes here, so this is the virtual IP that we're going to be using. All right, so first thing is let's bring up all the virtual machines. So let me first go to my play directory, and I'm going to git clone my Kubernetes repository, cd to Kubernetes, and then cd to kubeadm Keepalived Haproxy, external Keepalived Haproxy, and here we have our vagrant file and bootstrap. All right, so if I do vagrant up -- provider or libvirt, it's going to provision all those 6 virtual machines for me, and it's going to take a couple of minutes. I'm going to pause the video and come back when it's all done. Alright, the command completed, and it took less than a minute actually. And if I do verse list, you can see 2 load balancer, 3 master node, and 1 worker node, 6 virtual machines all running fine. Let me also open this up in virt manager so you can see that here, and I can also do vagrant status. Okay, so we have all of our virtual machines running. Let's continue following the documentation. So I did vagrant up provider libvirt, and now first thing first, we're going to be setting up our load balancer nodes. We're going to be installing Haproxy, Keepalived. We're going to have a couple of configurations for Keepalived and Haproxy and see how this virtual IP actually works. Okay, right, the first thing is install Keepalived and Haproxy. Let's do that, and I'm going to be doing this on both load balancer 1 and load balancer 2. So for that, I'm going to open up another pane here, and let me SSH to 51 and to 52. So that's load balancer 1 on the top pane, load balancer 2 on the bottom pane, and I'm going to synchronize my pane. So if I run the command on 1, it's going to get executed on both the panes as well. Right, the password is kubeadm. That's coming from the bootstrap script. The first thing is we're going to be installing Keepalived and Haproxy. Let's install that. Right, Keepalived and Haproxy package is installed, and now configure Keepalived. So what we're doing here is we are creating a check script, a health check script in etc Keepalived check API server.shell. And if you look in here, what we are basically doing is Keepalived is going to use this health check script to find out if the API servers are reachable from the from the load balancer node. So basically from this load balancer, when we do the Haproxy configuration, this load balancer will be proxying requests to one of the 3 master nodes in a round robin fashion, right? So we need to make sure that the load balancer can talk to the master nodes via the Haproxy configuration. So that's the check we are doing in this check script. And if the check script fails, the load balancer, the Keepalived, assumes that this load balancer has problem communicating with the control plane nodes. So it will switch the virtual IP to another load balancer. And similarly, if that load balancer has got problems accessing the API server, the virtual IP will get switched to one of the other load balancer. In our case, we only have 2 load balancers. Okay, let's go back to the documentation and run this. So basically creating the script and setting the executable permission for that script. Okay, so copy that and paste it here. Right, so that's just the health script, and here is the actual Keepalived configuration. It's a very simple Keepalived configuration. You can see the virtual IP address here, 172.16.1600, which will be managed by Keepalived, and we have this track script. We specified that to be check API server, and that is here, check API server, this code block, and when it calls this code block, this script will get executed. So let me explain you what this check is going to do actually. So interval is 3, so Keepalived Keepalived is going to run this health check script every 3 seconds. Timeout is set to 10 seconds. So if it waits longer than 10 seconds, for example, the Haproxy node, when it tries to do this command here, the curl command to https localhost:6443, which will then forward it to one of the master nodes. And if it didn't get any response within 10 seconds, it assumes that particular health check run has failed. Okay, and fall 5 means it has to fail 5 times consecutively in order to assume that the node is actually failed. And rise 2 is it has to succeed 2 times consecutively in order to assume that the node is back online again. Wait -2 means when it fails consecutively for 5 times, it's going to reduce the priority of the load balancer node by 2. So further down here, you see I initially set the priority to 100 for both the load balancer 1 and load balancer 2 nodes. State is backup. So ideally, one of the load balancer node will have the state as master and the other one will have the state as backup. And you should have a high priority for one of the node and low priority for another node. But to keep things simple, I've set the priorities same for both load balancer 1 and load balancer 2. But when it starts for the first time, it will identify which one to become the master, right? So we have the virtual router ID. So it has to be a number between 1 and 255. The Keepalived process communicates with the other Keepalived process on the 2 load balancer nodes. It's kind of like a heartbeat. So it periodically checks every 5 seconds. It checks whether the other node is available. If it's not, then the current node will become the master. So that's how the virtual IP shifts between the 2 load balancer nodes. Let's copy this, paste it on the 2 load balancer nodes. Right, systemctl enable -- now Keepalived. It's going to enable the Keepalived service as well as it's going to start the process. Let's do that. Right, that's done. And if I do systemctl status keep alive, the Keepalived process is running on both the nodes now. All right, so if I do journalctl -f to follow U for unit, the service unit we are interested in is Keepalived. And you can see here one of the node has become the master, right? So you can see here changing the effective priority from 100 to 98. That's because the script, the health check script, check API server that we created actually failed, because the check we've actually done is to see whether the load balancer node can communicate to the API server using this address. So this is basically running on the load balancer node on 6443. We haven't got to the Haproxy configuration. So basically in the Haproxy configuration, if we hit the port 6443 on the load balancer, it's going to forward the traffic to one of the 3 master nodes. Okay, so we haven't set up the Kubernetes cluster yet. We haven't set up the Haproxy configuration yet. So this command is going to fail, the curl command. So this health check script also checks another endpoint. So it also checks whether we can reach the API server using the virtual IP, which is 172.16.16.100. So it checks whether the current load balancer node has the virtual IP. If it has the virtual IP, it also checks whether we can reach the API server through the virtual IP. Okay, it's understandable, right? So this script failed on both these load balancer nodes. The check API server failed, and that's why it has reduced the priority from 100 to 98. So that is this wait -2. So whenever the script fails, it reduces the priority by 2, basically. So we don't have to worry too much about that. So once we configure Haproxy and once we complete our Kubernetes cluster initialization, then it should all be okay. But for now, you can see load balancer 1 has become the master and load balancer 2 has become the backup. And the other thing to note is you can look at, sorry, I forgot to mention, there's one important thing. This interface here, ETH1, is the interface where Keepalived is going to attach the secondary IP address, the virtual IP address. So in my case, I've used ETH1 because all my virtual machines has 2 network interface. Let me show you. IP address show, you can see ETH0, that's the default network. And using my Vagrant file, I specified a custom network range. So ETH1, I always want to be using ETH1. In your case, you may not be using, if you're using a physical server or a different virtualization, if you're not following my Vagrant file, you may have just one interface, ETH0. So in that case, you need to update this interface to the right interface. So in my case, it's going to be ETH1. So if I do IP address show ETH1, you can see there is this virtual IP 172.16.16 100 attached to the load balancer 1. So now the virtual IP is pointing to load balancer 1 at this point. Right, let's continue setting up our Kubernetes worker nodes. So our Haproxy, our Keepalived is complete. So now we need to configure Haproxy. We've already installed the Haproxy package, and now we are going to add this one. So basically we define a front end in Haproxy. So that's where we are actually listening. So you can see here on the load balancer node, we are listening for traffic on port 6443. The default backend is Kubernetes backend, which is defined here, and all the traffic coming to 6443 will be routed to one of these 3 nodes in a round robin fashion. Where is it? Yeah, balance is round robin. Right, so let's copy this Haproxy configuration, paste it in both the load balancer nodes. Systemctl enable Haproxy. Haproxy should be enabled already by default if you're using Ubuntu machine, but if you're using CentOS, the service might not be enabled by default. But anyways, we are going to enable it and then restart the Haproxy service. Right, so we have Haproxy service running. So now we can go ahead and configure all our Kubernetes nodes. Right, so there are some prerequisites that we need to be running. We need to do on all of our Kubernetes nodes, both master nodes and worker nodes. So for that, I'm going to open up a new window and I'm going to open up 4 panes here. So on the first one, I'm going to log into 101, and in the second, 102, which is kmaster2, and in the third I'm going to log into 103, and in the 201, that is kworker1, and I'm going to synchronize the pane. Password is kubeadm. Right, so we've logged into all of our Kubernetes nodes, 3 master nodes and 1 worker node. Let's follow the documentation. The first thing is disable swap off -a, and then we also disable it in the etcfs tab so that it doesn't turn on when we reboot all of our nodes. Right, so let's run this command. Right, that's done, and then we disable the firewall. Right, so next thing is we need to load some kernel modules, couple of kernel modules, overlay and BR net filter. So this one will load the kernel module for this current session, and we also put that in a file so that every time we reboot the machine, the kernel module gets loaded. So copy that. That's done, and we're going to add kernel settings again. sysctl system will apply for this current session, and we also put that in a file so that it gets added every time we reboot the system to make it permanent. Copy that. Right, that's done, and the interesting bit, installing the containerd runtime. So I've stopped using Docker as the container runtime. For a very long time I've been using containerd as the container runtime. Let's do that. So this one is going to take a minute or so. All right, containerd installed, and now we're going to add the Kubernetes repository. Right, Kubernetes apt repository added, and now we're going to install Kubernetes components, kubeadm, kubelet, and kubectl version 1.22.0. Okay, so Kubernetes components installed on all the nodes, and now we are going to bootstrap our cluster. So the following command, kubeadm init command, we are going to be running just on one of the master node. You can pick any node, it doesn't really matter. So I'm going to pick the first node, kmaster1, where we are going to initialize the cluster. So once the cluster is initialized, we will then add our other master nodes and worker nodes to the cluster. So let me turn off the synchronization so I don't accidentally run this init command on all the nodes. So now I'm just running the commands on kmaster1. I'm going to make it full screen. Okay, so we are on kmaster1 and we are going to be running this command. Right, kubeadm init, the extra option, the difference here is because we are initializing a multi-master Kubernetes cluster, we are not going to specify a single master node. Instead, we are specifying, by adding this option control plane endpoint, we are specifying that all of our cluster components will communicate with the cluster using this control plane endpoint, and which is nothing but the virtual IP 172.16.1600, which is at the moment attached to load balancer 1 on port 6443, and that will proxy the request to one of the master nodes behind the load balancer. And we also have this option, API server advertise address. Again, if you are just using one network interface interface, you don't have to worry about passing this option. In my case, I've got two network interface, and I want to make sure that I use the second network interface, which has the address 172.16.16.101 for kmaster1. If you're running this command on kmaster2, make sure to update this IP address, and the pod network seeder is 192.168.00/16. We will be using Calico as the overlay network, so we need to set the pod network seeder accordingly. Okay, so this command will initialize the Kubernetes cluster. It will take a minute or so. Let me pause the video and come back when it's done. Okay, kubeadm init command completed, and if you look at the last few lines of the output, you can actually see the cluster join command that you will be using to join other master nodes and worker nodes. So you can join any number of control plane node, the master nodes, by just running this command as root user kubeadm join command. And further down, you also have the command that you need to run on the worker node to join the worker node to the cluster. So let's first join our master nodes. Okay, so I'm going to copy this command, exit out of the full screen, and I'm going to go to kmaster2, make it full screen, and I'm going to paste that. So remember to add --API server advertise address 172.16.16.102. This is kmaster2, and again, you don't have to do this if you've got just one network interface. This is just needed only on the master nodes, because the master nodes are the one that runs the API server component. Okay, so the command completed. Let me exit out of the full screen. Let me also clear the screen. So now I'm going to run the same command on kmaster3. Let me make it full screen and paste the command and add --API server advertise address is 172.16.16.103. Okay, so the command completed. Let me exit out of the full screen, clear the screen. So now let me go back to kmaster1 and copy the last command that I need to run on the worker node. So copy that, and then in kworker1, let me make it full screen, paste the command. So here you don't have to pass in the API server advertise address option because this is not an API server. So I'm just gonna hit enter. Okay, so that has completed. Let me exit out, and I'm going to go back to the master kmaster1. There is one last thing that we need to do. We haven't deployed our overlay network Calico, which I'm going to do. If I go back to the documentation, so this is the command that I'm going to run. Project Calico version 3.18, copy that, and kmaster1. You can actually run this in kmaster1, kmaster2, or kmaster3, it doesn't really matter. Deploying the Calico. Alright, so that's all well and good. So I'm going to exit out of kworker1, and I'm also going to exit out of kmaster3. Right, so I'm back on my host machine in the bottom pane here. So now I'm going to copy the kubeconfig file from one of the master node to my local machine. So for that, I'm going to make a directory .kube under my home directory, and I'm going to run an scp command root at 172.16.16.101, which is kmaster1. You can just copy this. etc kubenetesadmin.conf file is going to be there on every master node, so you can just basically copy it from any of the master node and copy it to the .kube directory that we created previously as config. And the password is kubeadm. Right, so I've got kubeconfig copied to my local machine, and now I can run cluster commands. kubectl cluster info. Yep, our cluster is good, and you can see the cluster, the interaction is through the virtual IP 172.16.16.100, which is again pointing to load balancer 1. Let's also look at kubectl get nodes. Yep, we have 3 master and 1 worker. Everything is ready. 1.22.0. If I do -o void, you can see we are running containerd runtime version 1.5.2, Ubuntu 20.04. Alright, so now what I'm going to do is I'm going to run kubectl get nodes in a loop, so it runs every 2 seconds, and I'm going to show you what happens if we bring down one of the master node and things like that. So basically we are now in the testing phase. We have completed our entire setup. We've got the load balancer plane set up with Haproxy and Keepalived, virtual IP pointing to load balancer 1, and we've got the multi-master control plane with 1 worker node, and we are running our commands using kubectl on my local machine. Alright, so it's running every 2 seconds kubectl get nodes, and now because our control plane is highly available and it's being served through the load balancer, now we shouldn't be having any problem bringing down any of the master nodes. So let's simulate this. So kmaster2, I'm going to, let's say, power off. And just to make sure, I'm also going to do it because sometimes it hangs while shutting down the master node. So if I go to the work manager, the one that we shut down is kmaster2, and I'm also going to force off. So definitely kmaster2 virtual machine is down, and back in here soon you will see kmaster2 status is going to be not ready. So we've definitely brought down kmaster2, and still we are able to access our cluster. kubectl get nodes command is running fine, and there we go, kmaster2 is not ready. Let's bring this back up. So let's start it. And once the machine is up and it starts the kubelet service, you will see kmaster2 back online in service, ready to accept the traffic. Yep, kmaster2 is now ready, so that's fine. And the next thing that we could actually do is, if I log into 51 kubeadm, so that's our load balancer 1, and let's log into load balancer 2 as well, kubeadm. Right, so at the moment we are able to access our Kubernetes cluster. What if one of the load balancer node goes down? So if I show you the IP address 80H1 and on this node as well. Right, so as of now, as I said, the virtual IP is now pointing to 172.16.1600 is pointing to load balancer 1, and load balancer 2 doesn't have that IP address, and all the traffic from our kubectl, from all the cluster components, is going through load balancer 1, and that's being in a round robin fashion going to one of the master nodes behind it. Okay, so let's say load balancer 1 is currently serving the traffic, and I'm going to reboot this server. Right, so that's gone, and still your kubectl get nodes command is returning things because it's going through load balancer 2. Okay, let me show you what is actually happening. And in here, if I do ETH1, and you can already see the virtual IP switched to load balancer 2, 172.16.1600. So I rebooted load balancer 1. Let's try and log into it. kubeadm. IP as address show, shorthand for address show ETH1, and we no longer have the virtual IP attached to load balancer 1. We were still able to access our Kubernetes cluster. Let me also show you the journal log, journal ctl Keepalived. Let's also do that from here, journal ctl Keepalived, and you can see here entering master state, and it says entering backup state, and the check API server script succeeded. That's all looking fine. So when we rebooted load balancer 1, the load balancer 2 became the master, and that's how Keepalived actually keeps track of which one it needs to make the master and which one it needs to make the backup. All right, let's do one more thing. So what we just did was entirely bringing down one of the load balancer. Okay, so that's one scenario. And if I show you this configuration we had for Keepalived, so as I said, Keepalived has a couple of things to check. So one thing is it checks every 5 seconds the backup actually. So in our case, load balancer 1 is backup now. Load balancer 2 has got the virtual IP, so that's the master. So Keepalived process in load balancer 1 will check every 5 seconds that the load balancer 2, the Keepalived process, is running on load balancer 2. So that's the advertised interval 5 seconds. And that's how load balancer 2 originally found that it didn't get any response back from load balancer 1, and Keepalived process switched load balancer 2 to master. All right, so that's fine. That's this heartbeat check between the two load balancer nodes. So what if the load balancer nodes are actually online? It's working fine, but it is not able to forward the request to the backend Kubernetes master nodes. So our testing was to bring down the load balancer. So that's obviously we need to take care of. If one load balancer node goes down, virtual IP switches to the other load balancer node. So what if both load balancers are running fine, but one of the load balancer has got problems accessing the Kubernetes? All right, so let's simulate that. So at the moment we know load balancer 2 has got the virtual IP address, let's say for some reason load balancer 2 is up and running, but it can't communicate with, there's a problem with Haproxy, or it can't communicate with the Kubernetes master nodes. So that's where the check script actually helps. Okay, let's try this. So I'm going to systemctl stop Haproxy. So virtual IP is attached to this load balancer node, and Haproxy is the one that's forwarding traffic to the Kubernetes master node. And if I stop the Haproxy service, the load balancer is actually running fine, and this is the backup. It knows the other one, the master, is actually working fine, but it's not actually doing its job, right? So if I do that, you will see temporarily there will be a loss of connection to the Kubernetes API server, but that's fine because it has to wait for 5 times to fail consecutively with an interval of 3 seconds. So now this one, load balancer 2, the checks Keepalived executes that check script in load balancer 2 every 3 seconds, and it has to fail continuously, consecutively for 5 times before it assumes that this node is actually down, at which case the load balancer, the virtual IP, will get switched to load balancer 1, and you can already see we are back on track. So now kubectl get nodes command is running fine, and if I do IPAS ETH1, we no longer have the virtual IP attached to load balancer 2, and if I do the same here, and 172.16.1600 is now attached to load balancer 1. So that's how it actually works, and I think that's all I wanted to show you in this video. So as I said, you can obviously have more number of load balancer nodes. So in my next video, maybe we can try, instead of having Haproxy Keepalived on a separate virtual machines, we could try and integrate that inside the master components as static pods and see how it actually works. All right, so give it a try and let me know if you've got any questions. I'll be happy to help, and I will see you all in my next video. Until then, keep learning and keep on learning. Bye bye.